What's going on, chemistry nerds? It is time for us to do a quick recap on atomic and ionic radius. Okay, so this is in the unit of periodicity of the elements, or periodicity for short. All right, let's recap. Atomic radius is a measurement of the size of atoms, and we usually consider that to be the average distance from the center of the atom, so the nucleus, to the outer edge of the surrounding shells of electrons. So just remember some basic geometry here. Radius is half the diameter of a circle or a sphere, so from the center to the outer edge. So essentially, it's telling us the size of atoms. Now, yeah, we know that atoms are insanely small, but that being said, there are some atoms that are a little bit bigger than other atoms and smaller than other atoms. Okay. So, again, compared to a human being, yes, all atoms are crazy small. But compared to each other, there is actually a size difference. So, let's practice using the periodic table and the reference tables to figure out what's going on here. Okay, so I'll go back through my warm up here because I think it helps to show what's going on. So this says look up the atomic radius of elements in period 2, starting with lithium, and let's see what happens. All right, so let's go to the reference tables. Okay, so first, let's see. Actually, I always forget I got this new tool here. Oh, yeah, I could do that. Cool. Okay, so period 2 is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, all the way to neon. Okay? So we're looking across period 2 as atomic number, which don't forget is the number of protons, the positive particles in the nucleus, increases. So we're going to be going from left to right. So again, starting with lithium and we'll end at neon. And for the heck of it, I just want to check out helium too, since that's to the right. But overall, we're going to stay in period 2. Okay, so let's see what happens when we check the atomic radius, which is given over here. So if you notice, atomic radius is given to us on reference table S, and it's given in PM, which stands for picometers, which is trillionths of a meter. Crazy, crazy small, okay, which makes sense because these are atoms. Okay, so the odd one out here is going to be helium, which has a radius of 37, which is very, very small for an atom. And let's go from left to right, starting with lithium, like I originally said. So these are the elements in period 2. So lithium has a radius of 130 picometers. Then going to the right, we have element number 4, which means, don't forget, atomic number is the number of positive protons in the nucleus. You like how clean my handwriting is? So beryllium, the atomic radius is 99. Boron, element 5, it's 84. Carbon, 75. Nitrogen, 71. Oxygen, 64 picometers. Fluorine, 60. And neon, 62. So do you notice what's happening when we start at lithium and end at neon is, for the most part, as we went to the right across period 2, the atoms actually started to get smaller. Okay? So if you look at the numbers, we see that their radius decreases. Okay? So that means, if we recap over here, that as you go from left to right across a period, atoms get smaller and smaller and smaller. Okay, that's great and all, but like, what is going on here? Why is this and how is this happening? So let's look at that right now. Okay, so we have to remember something. We know that atoms are made up of positively charged particles in their centers, which is called the nucleus, and the particles that are positive are protons. There are the other particles in the nucleus, which are neutrons, which are neutral and have zero electric charge, and we're not really going to pay much attention to them right now. All right, and then outside the nucleus, we have the negative particles, which are electrons. So now think about this. As you go from left to right on the periodic table, right, across a period, that means that there are more and more and more protons, right? Lithium has 3 protons, beryllium has 4, boron has 5, carbon has 6, nitrogen has 7. So basically what's happening is there's more and more and more of a positive charge in the nucleus. So let's think about what's happening. As you go towards the right of the periodic table, the atomic number, the number of protons, increases. So this means that there's more and more positive charge. So this stronger electrostatic attraction pulls the negative electrons in towards the nucleus since there is a greater positive charge. Yes, there are more electrons in the atoms, but they're in the same energy level, meaning they're in the same shell. So remember, right, as we go to the right of the periodic table, here, let me go show you on the simulator, right? So lithium has 3 protons. Okay, so now we go to beryllium, has 4 electrons, but if you notice, they're in that same second energy level. What this simulator is not showing is that as you go to the right of the periodic table, where you have elements with more and more protons, the atom actually shrinks a little bit, okay, as there's one more proton. So that's what's happening. So elements towards the right are smaller because there's more protons attracting the electrons inwards. Okay. What about if we look down a group? You know what? Before I go to the lesson notes, why don't we actually try to check it out ourselves on the reference table? So let's see. What if we go to group 1 and look down the group in terms of increasing atomic number? So mind you, if we stay in the same group, as we head down, we're going to be going from period 1 to 2 to 3 to 4 to 5 to 6 to 7. All right, so in this case, if we stick in group 1, it's going to be hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Okay, let's see what happens with their atomic radius as we go down. So hydrogen, starting us off, has 32 picometers as the radius. And then we go down to the element in group 1 below in period 2, which is lithium, which has a radius of 130. And then we'll go down to the next period in group 1, which is sodium, which has a radius of 160. And then we'll go down to the next period. And again, we're staying in group 1. Potassium has a radius of 200 picometers. Oh, we got to keep going. Period 1, no, not period 1, group 1. What's the next element? I believe it's cesium. Or is it rubidium? There we go, rubidium. 215, right? Am I forgetting my order? Rubidium, then cesium. Aha. So now we got to look for cesium. So rubidium is 215. Cesium, cesium, whatever. Oh, there you are. 238. And francium, 242, which is, I believe, the highest atomic radius shown on this list. So again, we could see that if we start at the top of group 1 and head down, the atomic radius is increasing. So as we go from hydrogen down to francium, atoms get much, much, much bigger. So again, what's going on here? All right, back to the notes. So what's happening is, remember, the period number tells us how many electron shells are around an atom's nucleus. So as you go down a group, you keep hitting bigger and bigger period numbers, which means that the atoms have more and more electron shells around them. So the number of electron energy levels, or we could just call them electron shells, it increases in each successive period as you go down a group, meaning that the outer electrons, which are the valence electrons, are farther and farther away from the nucleus each time you get to a new period down the group. So as we go down a group, the period number increases, which means there's more and more electron shells around the nucleus, and therefore the atom is bigger. Okay. So what happens if we put those two ideas together? That as we head to the right, there's more protons and electrons get pulled in towards the nucleus, and atoms shrink. And as we go down a group, there's more and more electron shells because you're going to lower periods. Well, if we put that all together, we get this. You could just basically remember that overall, aside from a few hiccups, right? Some atoms are a little weird. They are a little bigger or smaller than you would expect. But we could just remember, if you go towards the bottom and towards the left, atoms get bigger. There we go. Atomic radius gets larger as you go down and to the left. Boom, done. Okay, again, there's a few hiccups, but this is the overall trend. Down and to the left, bigger atoms. Okay, there we go. Now, the second part of this is atoms usually don't stay as neutral atoms during a chemical reaction. Well, they can, but a lot of times atoms will give away or gain electrons. So let's see what happens here. So let's look at the metals, which are over here on the left side of the periodic table. Oh no, I'm drawing things when I didn't want to. Okay, so if we look, for instance, at, oops, trying to clear all the drawings on here. Sorry, too many things going on my screen, too many things. All right, so if we look at the elements, let's say lithium, for instance, if you notice at the top right, it gives an oxidation state of +1. Now, that doesn't mean that a lithium atom has a +1 charge. Let's recap on that really fast. Let me go back to, I'll make a lithium atom really quick. Oh, come on. There we go. All right, so lithium is 3 protons, 1, 2, 3, 4 neutrons. And again, if we want a neutral atom, we need the same amount of electrons as protons. So right now we have 3 protons and 3 electrons, right? So we have 3. Oh, it's not letting me write on the screen. Great. Well, I hate you too. All right. So we have 3 protons and 3 electrons. So that means if you look at the top right over here, right, we're going to be seeing a 0 charge. So now that's what you got to remember about the periodic table, which is that any neutral atom, you should be picturing an invisible 0 up there. Okay? So there should be an invisible 0 at the top right. Oh, my camera turned on. Cool. Hi. Accidentally clicked on that. There's a new function here I wasn't used to. So you want to picture a 0 charge. So what is this +1 showing? Well, what that's telling us is that after a chemical reaction, lithium atoms tend to give away that outer valence electron, that 1 electron. Here, I'll go to the simulator and show you. So what happens is metal atoms tend to give away electrons to other atoms. Do you see what happened? Now, lithium has lost that electron in the outer shell. So now it's a positive ion because now there are leftover protons in the nucleus, right? Those didn't change. So there's 3 protons, but only 2 negative electrons. So 3 positives, 2 negatives. 3 minus 2 is +1. So now we have a lithium positive ion. But here's the thing, and I'll try to draw it terribly because I can't draw. But let's think about this. So we have the lithium nucleus, that's positive, right? And it has 2 electron shells. It's got 2 electrons in the first shell and 1 electron in the outer shell. But the thing is, we said that in a chemical reaction, what can happen is that metals give that outer electron away. So watch this. When that outer valence electron leaves the atom, look what happened to the size. Watch that again. It shrank. So what this means is that when you notice a positively charged ion, that means that it lost electrons. And that means that a positive ion, since that means that an atom lost electrons, it's missing electrons. It's always going to be smaller than it was originally. So positive ions are always smaller than their original atom, okay? Metal atoms tend to lose electrons and become positive, what are called cations, and their radius decreases, okay? So when you notice a positive ion, it is smaller than the original atom was. Now, what about negative ions? So let's go back to, let me clear this, and then we'll go back to the periodic table and see what's going on here. Okay, so again, now we know that a positive ion is smaller than the original atom because it lost electrons. But what about, see how the metals have a positive charge most of the time? Or actually, no, all the time? That's because metal atoms lose electrons. But what happens if we go and check out the nonmetals, which are on the right side of the periodic table? So let's go check that out. It'd be great if this guy would let me move the screen. There we go. All right, what about, let's say, oxygen, right? You see how oxygen shows a -2? Now remember, that's not how atoms start off. They always start off with an invisible 0. So what's this -2 mean then? Well, a negative ion means that electrons were gained. So am I allowed to make oxygen on this simulator? Let me see. Okay. Can I get to oxygen? There we go. Okay, cool. So let me give the correct number of neutrons. And let's make a neutral atom first.
These came back from a search.
I'm not searching Google. Be quiet. All right, so now if you notice, this is an oxygen neutral atom. So the charge is 0, right? So we have 8 protons and 8 electrons. So what's up with that -2? Well, oxygen, like when you burn paper or something, what you're actually seeing is oxygen atoms stealing 2 electrons from other atoms. This makes an oxygen atom stable. But the thing is, if you notice, there are now 2 extra electrons than protons. So now there's 10 electrons and only 8 protons. So we have 8 positives, but 10 negatives. 8 minus 10 is -2. So when you see a negative ion, that means that an atom has gained extra negative electrons. Now think about this, and again, it's not being shown properly in this simulator. What happens, and I'll try to draw it, again, forgive my drawing capabilities or lack thereof here. But let's say we have oxygen. So we have an oxygen atom. So again, it's got a positive nucleus, and it's got 2 electrons in the first shell, and then 1, 2, 3, 4, 5, 6 electrons in the outer shell. But the thing is, oxygen likes to steal electrons from other atoms. So if it gets 2 more electrons put in there, what happens is, now that there's more electrons, don't forget, each electron has a negative charge, right? And remember that opposites attract, right? Positive and negative want to come near each other. But remember that likes repel. So when you put a positive next to a positive, they want to push away, and negative next to negative, they want to push away. So now, because there's extra electrons, what actually happens to the atom is it puffs out a little bit more than it was before. It gets a little bit bigger because there's more electrons. You know what? We experience this in everyday life. If you have long hair and in the winter when it's dry out, somebody's hair might stand up. So what's happening is this happens when you get extra electrons on your hair, or electrons could be pulled off, which means that your hair strands all become the same charge, right? So let's say you get a lot of electrons on your body and they go to your hair. That means that your hairs will all be negatively charged. Well, if they're all negative, they push away because that's how the law of electromagnetism works. So it's a similar thing that's going on here. So what happens when an atom gains extra electrons is it gets bigger. So nonmetal atoms tend to gain extra electrons and they become negatively charged, what are called anions. And because there's extra electrons that want to kind of push away from each other, their radius increases and gets bigger. So if we recap on all of that, just remember this. Metals tend to lose electrons. Since electrons are negative, when there's missing electrons, that means there's now more positive protons than electrons, and you'll end up with a positive ion. And remember that a positive ion is an atom that is missing electrons. So if there's less electrons, the atom is now smaller than it was before, and well, we wouldn't call it an atom anymore, we'd call it a positive ion. So a positive ion is always going to be smaller than the original atom. And again, we call them cations. What helped me is that the letter T looks kind of like a plus sign. Okay, so metal atoms lose electrons, become positive, and they shrink. Nonmetals tend to attract extra electrons, and they become a negative ion, and they actually get a bit bigger than they were before. And that's it. So again, this diagram I found online works really well. It shows that if you start with a metal atom, which is gray, that will be bigger than a positive metal cation. And if you go to the nonmetals, which is the gray spheres to the right, when nonmetals gain electrons, which is the blue ions, you notice that the blue negative ions are bigger than the original atom was. There you go. All right, I hope that helped and did not confuse, and I hope you're not having a frizzy hair day.